Now, let us discuss uniform circular motion. When an object follows a circular path at a constant speed, the motion of the object is called uniform circular motion. A whirling bucket of water. Now see, a moon moves around the earth in a circular path. Uniform refers to the speed which is constant throughout the motion. Why is uniformly circular motion called accelerated? Although the speed of the object remains uniform throughout, its velocity keeps on changing continuously in direction, and hence the object undergoes acceleration. Let us find the magnitude and the direction of this acceleration. Let r and r dash be the position vector and v and v dash the velocities of the object when it is at p and p dash respectively. Using triangle law, we find delta v since the path is circular. Here, velocity vector is perpendicular to r vector and v dash is perpendicular to r dash. Hence, delta v is perpendicular to delta r. Now, average acceleration a vector equals to delta v divided by delta t is along delta v. Using equation 1, delta v vector is perpendicular to delta r vector. So, acceleration vector is perpendicular to r vector. Thus, we find that acceleration of the object in uniform circular motion is always directed towards the center of the circle. So, modulus of A equals to magnitude of the acceleration. So, modulus of A equals to limit delta t tends to 0 modulus of delta v divided by delta t. Triangle CPP dash and MNO are similar as angle between v and v dash is also delta theta. Ratio of the base length to the side length for one of the triangle is equal to that of the other triangle. That is, modulus of delta v divided by v equals to modulus of delta r divided by capital R. Taking v on the right hand side, we get modulus of delta v equals to v modulus of delta r upon capital R. Substituting the value of modulus of delta v in the equation, modulus of A equals to limit delta t tends to 0 modulus of delta v divided by t, we get modulus of A equals to v by r limit delta t tends to 0 modulus of delta r divided by delta t. If delta t is small, delta theta will also be small. Then pp dash will be approximately equals to modulus of delta r. So, modulus of delta r will be equal to v delta t. V equals to modulus of delta r upon delta t equals to limiting value delta t tends to 0 delta r upon delta t. Substituting v in the equation of acceleration, we get modulus of A equals to v upon r into v. Thus, acceleration of the object has a magnitude v square divided by r and is directed towards the center. This is why it is called centripetal acceleration. Another way of describing velocity and acceleration, we define angular speed omega as omega equals to delta theta divided by delta t. Let the distance traveled by the object during t time is s, that is pp dash is delta s. Then v equals to delta s by delta t. Substituting delta s equals to r delta theta in the above equation, we get v equals to r delta theta upon delta t equals to r omega. So, centripetal acceleration AC equals to v square divided by r equals to r square omega square divided by r, that is r omega square. Note that time taken by the object to make one complete revolution is known as time period t. The number of revolutions made by the object in 1 second is called its frequency v, and the relation between frequency and time period is given by v equals to 1 by t.